All right, so let's go ahead and now let's examine a two-way ANOVA analysis. So I want to look at basically two factors, fertilizer again, and then I also want to look at density. So density has a factor of only 1 and 2. So if you look at that second column in here, that is my density factor. So let's do one-way ANOVA with my two data sets, and I'm going to specify fertilizer, then density, and then give me all of the interactions that could occur. So I'm going to get fertilizer, density, and the combination of the effect of density and fertilizer. So I run my analysis, and we can see again. So I see that fertilizer is important, density is statistically significant, but density and fertilizer together as an interaction, they are not statistically significant. So what about the significant interactions between each other? So here I could see for fertilizer, same thing. 1 and 3 are statistically significant, 2 and 3, that makes sense. And there is a difference between high density, or 1 and 2 for my density as well. And what I can see here, and if I look at these values, so fertilizer 3 again has the highest mean, excellent. Density 2 looks like it's going to have the largest effect because there's larger mean here. And you can see that a lot of these values are very similar, but if we look at it, density 2 and fertilizer 3, they have the largest mean effect. So if I want the highest yield, I want to combine 2 and 3. So, because this gives me my largest mean, the yield effectively here. But again, we see these effects. Now, how do we know what has the? Well, we can actually see which of these effects is larger or significant by effectively looking at the sum of the squares value and calculating an eta squared value. So our eta squared values is effectively going to be the sum of the squares of the effect. So the sum of the squares of fertilizer and density respectively divided by the sum of the squares of the effect plus the sum of squares of air. So this. So we're going to take this plus this divided by this plus this. So it's basically kind of this dimension, this number, this fraction. So if the effect is greater than, or if this ratio is greater than 0.14, large effect. If it's between 0.06 and 0.14, medium, and it's small if it's less than basically 0.01. So we see it's 0.16, so large effect. Here, large effect as well, pretty close, but it could be almost basically in that medium range. But anyways, so we can see essentially and quantify, is this a large effect or small effect? Now, next time we'll get into three-way ANOVA. So we'll see you in the next video.